Alright guys, so this is the third video for the review, and these are all like calculator type problems, so we're gonna go ahead and get through these. So two things here. This is what we learned on Tuesday. Okay, this is the last stuff we covered. So since this is the angle they gave me, let's go ahead and call it theta, because the first thing they want me to do is write an equation for the missing side. So we're assuming this is the only information I don't know, is this right here. So this right here, this is my opposite side, which means this is my adjacent, and over here is the hypotenuse. And for right now, guys, we really don't care about the hypotenuse. When we get into the next chapter, we'll cover that a little bit more. So right here, what I'm doing now is I'm going to solve for, or create an equation to solve for x. So here, since I know I have the opposite and I want to know the adjacent side, the equation I'm going to deal with is theta, excuse me, tangent theta. Opposite over adjacent. Okay, so as you remember, right now I'm assuming I don't know what this angle is. So this is tangent theta equals my opposite, which is 3, and my adjacent, which I'm calling x. That I don't know, and I want to solve. I want to make the equation, so I solve for x. So what I would do is multiply by x, so it cancels. So it looks like that. So x tangent theta equals 3. And then again, I want x by itself, so I'm going to divide by tangent theta. Divide by tangent theta. Okay. And when I simplify this, it equals 3 over tangent theta. So this is part A. This is what it's asking for. Make the equation. Part B is to actually solve it. Okay, so guys, I know the angle. It's 54 degrees, so let's just plug that in. Tangent 54 degrees. So when I do that, I find that my answer for x is equal to 2.2. Okay. So, moving on. If I had a big question like this, again, guys, we're same concept here. So this right here is theta. We're gonna assume we don't know what that angle is for right now. So I want to know this side right here. What's the height of the building? So this is my opposite side. They gave me my adjacent, and this is my hypotenuse. But again, right now I don't care about that. I want to know h, and I know a. So O and A, that means I'm going to use my tangent equation. So this becomes tangent theta equals opposite, which I'm calling h or x. I mean, it doesn't matter. And my adjacent, which is 57. Okay, so I want h by itself, so multiply by 57. So h is equal to 57 tangent theta. Okay, so let me see if I solve for the height of the building using the angle. So again, guys, here 57 times tangent of 55 degrees. Okay, and if I solve that, oops, I don't have that number on me right now, so let me just calculate it real quick. The height of the building is 81.4 well, inches, so this is not very accurate, but that's what it equals. Okay, so when I'm dealing with the tangent graph, guys, okay, so there's really only 2 points you need to put. This one, or excuse me, 3 points. Well, one that always goes through 0, 0, because we're not shifting these. Go ahead and plug something in for 45. So again, if I have my equation, you just plug in for 45. Okay, and when I do that, I get that it equals 57. So I know this is not very accurate, guys. I know this says 10 over here, but we'll just mark it here. This is 45 and 57. Okay. Now, what I need to remember also is I'm just graphing from the interval of 0 to 90. So remember, at 90, I have an asymptote. So it's never going to reach this line. And if I were to plug 90 into my calculator, we're going to see that it's undefined at that point. Okay, and that's because there's an asymptote there. Okay, so what I would do is, we know this is going to rise way up here. I would use a number like 89 to define it. Okay, and so I know that I have another point up here at 89 and, whoops, sorry, right it wrong, 33,266. Okay, and I see that my graph starts moving up really fast. Okay, so maybe I'll keep going on forever and ever, but again, so I found that number by plugging in an 89 degrees, and it equaled 3,266. Okay, so that's my graph. All right, so last questions here, I believe. Sorry, still a little bit more. Sector area, okay, and so here, this is an equation. You don't need to remember it. It's going to be given to you. Okay, so here, 1/2 times r, which I know is 7 squared, and theta, which is 135 degrees. Now, problem with this, guys, this theta, you have to remember, has to be in radians. So right now it's not in radians, so I'm going to multiply by pi on top, 180 on the bottom. Now I'm going to be in radians. So I'm going to type this entire thing into the calculator. So 1 divided by 2 times 7 squared times 135 times pi. Oops, I guess I should just put this. Okay, so times pi over 180, and so this equals 57.73. Okay, inches squared. Okay, so moving forward. Okay, so unit circles here, guys. Go ahead and practice it. Remember, you are responsible for all the stuff around it, the radians and the degrees. Know the sine, cosine, tangent, cosecant, secant, cotangent. Okay, and here, let's go ahead and go through these problems. So here they're asking for the angular velocity. I'm going to go through both of these with you. Well, at least some of it. Okay, so here, find the angular velocity. So here, guys, this is the equation. Theta divided by time. Okay, so here, if I read this, they want to know for the small pulley. And I know the small pulley is turning 120 revolutions per minute. Now, there's no radius in this one, so here, this is just 120. And since it's revolutions per minute, you can say it's per 1 minute. Remember, one revolution, guys, means it's one circle. Okay, so if I want to turn this, because right now it's not in radians, I have to multiply it by 2 pi. So 2 pi radians for every 1 revolution. So the revolutions end up canceling, and this would be 240 pi radians per minute. Okay. Okay, so moving on. Last one I'm going to cover here with y'all. Let's go ahead and find the linear speed, which I know is r times theta over t. So here they're saying the hamster runs inside his wheel. After 2 seconds, he's rotated 240 degrees. What if the wheel has a radius of 5 inches? Right now we're doing part B, so what's the linear speed? So here, again, this has to be in radians. So here my r is 5 inches. multiplied by an angle, which I know is 240 degrees. Okay. Divided by, 2 seconds. Okay. Now the problem with this right now is the 240 is not in radians, so I'm going to multiply by pi over 180, and that'll turn into radians. Okay, so this is my entire equation here. So 240 divided by 180. Okay, so this right here, if I want to simplify, 5 multiplied by 4 pi over 6. So I just simplified this part right here. 240 times pi divided by 2 and 180, which would equal 20 pi over 6, which is, you'll probably want the actual value here. So if I put this in the calculator, it equals 10.47 inches per second. Okay, so that's the answer for this one. And this is the 3 videos that you need to see for the unit exam.